This is going to be our first video in the trigonometric identities. And so typically we call these trig identities. And think of this, like I have over here, think of this as we're gathering tools for our toolbox. So in this video, we're going to gather a bunch of tools. And then in the subsequent videos, we're going to be using those tools. So we're going back here to our unit circle. And one thing we talked about in the unit circle is that the x value is cosine and the y value is sine. And that's for the unit circle where the hypotenuse is 1. And so one thing we've talked about, and I'll just kind of refresh our memory, is that the tangent of theta, which is this angle right here, is opposite over adjacent. So it would be sine over cosine. Sine of theta over cosine of theta. So that's your first trig identity, is that tangent is sine over cosine. And that's one of the tools that we're going to need in our toolbox. Some other identities we've talked about in previous lessons is that secant is 1 over cosine. It's the reciprocal of cosine. Cosecant is the reciprocal of sine. And cotangent is the reciprocal of tangent. So it'd be 1 over tangent. Well, if it's the reciprocal of tangent, then it's also going to be tangent flipped, so it'd be cosine over sine of theta. I should remember that, theta. So cotangent is cosine of theta divided by sine of theta. So these are 5 tools for a toolbox. We have 3 reciprocal identities, and then 2 other identities that are tangent and cotangent. So far, we've made some good progress. Make sure that you have these written down. If you're taking notes, feel free to pause here, get those written down, and then we're going to move on to the next set of identities we're going to learn. So the other big category is Pythagorean identities. And there will be more identities after this video, but these are kind of the main ones that you're going to use in the beginning of learning trig identities, are the 5 that we just looked at, and then these Pythagorean identities. So Pythagorean identities, this first word should give you a hint. The Pythagorean theorem is a squared plus b squared equals c squared. And if we look over at our setup of the unit circle, just like we did in the previous slide, the cosine is the x value, the sine is the y value, and our hypotenuse is 1. And since this is a right triangle, we can plug sine theta and cosine theta in for a squared, b squared, and 1 in where c is located. So what we're going to have is cosine squared plus sine squared. I keep forgetting theta. Cosine squared of theta plus sine squared of theta equals 1 squared. Well, 1 squared is just 1, so what we typically will write is cosine squared of theta plus sine squared of theta equals 1. And so this is one of your Pythagorean identities. This is kind of the main one you need to know, is this cosine squared plus sine squared equals 1. So, excuse me. I want to talk a little briefly about something that came up here. What's the difference between sine squared theta, sine of theta squared, and sine in parentheses, or parentheses sine of theta squared? So what's the difference between each of these? And let's look at that now. But if you didn't write down this, excuse me, here, get that out of the way. If you didn't write this one down, this is our first Pythagorean identity. We're going to write down 2 more in a little bit. We'll get back to that in a second. So let's answer this question down here on the bottom. What's the difference between these 3? So let's look at that. Sine squared of theta is, it looks a little weird, but this is really just saying sine of theta times sine of theta. So whenever you see the squared in between the sine and the theta, that would be sine of theta times sine of theta. So let's say we had sine squared of 30 degrees. This is going to be sine of 30 degrees times sine of 30 degrees. And let's see, if we think about 30 degrees on our unit circle, the sine is the y value, that is 1/2. So this ends up being 1/2 times 1/2, which is a fourth. So in this case, sine squared of 30 degrees is a fourth. So what's the difference between that and sine of theta squared? Well, what this one is saying is sine of theta times theta. You're squaring theta. You're not squaring sine in this case. So this would be sine of 30, well, sorry, let's back up here. An example would be sine of 30 degrees squared. And so this would be sine of 900 degrees. And let's see, 900, if we went around the circle once, that's 360. Twice would be 720. So 900 would end up being right about there. Well, not right about there. It's the same as 180. It's the same coterminal angle as 180. And the sine there is 0. So these are two completely different answers. Sine squared of 30 is a fourth, and sine of 30 squared is 0. So then we have a third thing. What about if we have sine of theta in parentheses squared? Well, this is, let me grab a fresh color here. This is sine of theta squared, so sine of theta times sine of theta. Well, it's the same as this one up here. So these two are interchangeable. You can write it either way. Typically, we'll see it like the first example there. But if you see it like the bottom example, it's the exact same thing. Okay, so that's one thing. And I remember as a student really being confused on what does this mean? I didn't really understand what it meant. So I wanted to kind of address that right away. So whenever you see squared on an angle, it's going to be the second example. Whenever you see squared on the sine, it's going to be the first example where we're squaring the sine. We're doing sine twice. Okay, so back to our Pythagorean identities. So what we're going to do is we're going to use what we already created. We have sine squared theta plus cosine squared theta equals 1. And I think on the previous slide, I maybe wrote it backward, where I put cosine squared first and sine squared second, but it doesn't matter. Addition is commutative, so we're good there. So what we're going to do is we're going to create two more Pythagorean identities. And for the first one, we're going to divide both sides of the equal sign by sine squared of theta. So I'm going to write this Pythagorean identity out again. Sine squared theta plus cosine squared theta equals 1. And then when I say divide both sides of the equal sign by sine squared of theta, that means everything gets divided by sine squared of theta. Excuse me. And so what we get then is sine squared of theta divided by sine squared of theta is just 1. Cosine squared theta divided by sine squared, well, cosine over sine, we looked at in the first slide, is cotangent. So this is going to be cotangent squared theta. And in the first slide, we said 1 over sine is cosecant. So this is going to be cosecant squared theta. So here is our second Pythagorean identity. So we have 2 of the 3 Pythagorean identities. One is up here in yellow, and the other one is down here in blue. So there's our first Pythagorean identity. Here's our second. To find the third one, we're going to divide both sides by cosine squared in this example. Got a little bit too far down. Let's scroll back up here. There we go. So I'm going to rewrite the original one. It's sine squared theta plus cosine squared theta equals 1. And then we're going to divide both sides by cosine squared. So divide this by cosine squared theta, divide this by cosine squared theta, and divide this by cosine squared theta. So maybe it would be wise to pause it and see if you can figure out what this is going to be. You should all be able to do that, hopefully, at this point, using what we've learned. So now we'll go over it. Sine squared over cosine squared is tangent squared. Cosine squared divided by cosine squared is just 1. And 1 over cosine squared is secant squared. So this is our third Pythagorean identity. And that is pretty much it. We've got all of the tools we need for our toolbox for now. One thing that might be nice is just to have a little summary sheet if you have a notebook and you want to write this stuff in there. Here's a nice summary of what we've learned so far, is that we've got these first two, tangent and cotangent. We learned about those two, and then we have the reciprocal identities, and then we have our three Pythagorean identities. So it might be nice to have this summary sheet somewhere. Now, one more thing, of course, it's always one more thing, right, is, two more things, I guess. We talked about how sine squared, but I've got something hidden here. And what I did for you, let's get rid of this, is I rearranged those three Pythagorean identities. And if we look at, let's see, I'll grab an arrow here, maybe. Let's see, there we go. Let's switch up the color to fuchsia, that looks pretty. So on this first one, there we go. I'm going to group this just so I can move that arrow around. Okay, so on this first one, what I did was of course, it ungrouped. Let's try that again. Group. There we go. Okay, take two. So, I'm not having any luck. Let me try this. So on the first one, I'll just use my pen. We've got sine squared plus cosine squared equals 1. To get the second version of that, all I did was I moved sine squared over to the other side, so I subtracted sine squared on both sides. So sometimes you'll end up with, you might see 1 minus sine squared, and you can say, oh, that's the same as cosine squared. Or you might see 1 minus cosine squared, and you'll say, oh, that's the same as sine squared. Or you might see cosecant squared minus 1, and that's the same as cotangent squared. So it just rearranged those three Pythagorean identities in different ways so that we have basically 9, but we really only need 3. And realistically, all you need is 1. As long as you know this first one here, let's kind of highlight that one. Let's use some fun. We'll do creative pen here. Let's do some stars. You really need to know this one. If you know that one, you can get the rest. The rest of them are all derivatives of that. All right, so I was long-winded enough there. Those are all of our all of our trig identities. And then also at the bottom here, make sure you remember that sine squared of theta is sine of theta times sine of theta, and that sine of theta squared is sine of theta times theta. All right, so that's it for trig identities video 1.